Hello lovelies, in this video we're going to be going through the Edexcel IGCSE Higher Maths Paper 1 that we've written for 2024. So you can use this to help you revise, use this to set of unseen questions and what we think might come up. Now, what we want you to do is to pause after each question comes up, have a go at it yourself in a bit of paper and then play the video and work through the answers together.
Here we're asked to show that 4 and 4/5 divided by 1 and 1/3 is equal to 3 and 3/5. Now this is to show that because obviously this is a calculator paper, but they want to see your method. So the first thing, let's change these fractions into top-heavy fractions. We do this by doing the 4 times the denominator and then plus that 4 of the numerator. So here we've got 4 times 5 and then we add on that 4. And it's all over 5, which was that denominator. That gives us 24 over 5. So we can rewrite 4 and 4/5 as 24 over 5. Next up we have 1 and 1/3. Again, if we take the whole number, times it by the denominator, and then add on the numerator, we will find what we need for our top-heavy fraction. And then we'll just divide it by that 3 that is already on the denominator. That doesn't change. And that gives us 4/3 for this fraction. So now we've got them both as top-heavy fractions, let's go back to what they're asking for. Here it's now looking like 24 over 5 divided by 4 over 3. Now this is a division, so I like to use the KFC rule, which states that we're going to keep it, flip it, and change it. Now, what this means is our first fraction in our division, we just keep it as it is, we're not going to change it. The second fraction, we are going to flip it upside down, and then we're going to change the sign from a division to a times. So now this is going to look like 24 over 5 times by 3 over 4, and that's using our KFC rule. So now we need to remember that when we multiply fractions, all we need to do is multiply the tops and multiply the bottoms, simplify if we can, and we're away. So 24 times by 3 gives us 72, and 5 times 4 gives us 20. Now this can simplify down a bit. We can see that both the bottom and the top are even numbers, so we can halve a few times until we end up getting what we need. This ends up giving me 18 over 5. This is even a point where you could now put this into the calculator and see how it simplifies. So 18 over 5 though, we should know that that is 3 and 3/5. We need to make that final link. The reason why that is the same is because in the number 18, you can get 5 3 whole times. So we have 3 as our whole number, and then we'll have a remainder of 3 because 18 minus those 3 5s gives us 3. So that's why we have 3 and 3/5, and we have shown what we needed to. Here we're asked to factorise x squared plus 7x plus 10. Now there's nothing that each of these have in common, so that means this is going to factorise to make a double bracket. Now when it's a double bracket question, you want to take the number which doesn't have any x's, and we want to find a pair of numbers that are going to multiply together to make that number, while at the same time adding together to make the coefficient of x, so in this case positive 7. So we need to find 2 numbers here that are going to multiply together to give us 10 and add together to give us 7. So I like to knock up like a little easy table here just in case it takes me a while. So my first instinct here is 2 times 5 will give me 10. Now if I add those together, I get 7. Well, I don't have to do any more. I've already hit the jackpot, which was quite lucky. It's not always the case. But if you don't get it first time, just keep writing different combos until you get the right one. So now, like I said, this is a double brackets question because there's nothing that goes into x squared, 7x and 10. So we're going to write our double brackets. We're going to write x plus 2 because we found 2 as one of our numbers, and then x plus 5, again because that's our other number that we found. And that is it factorised. So now we're asked to solve x squared plus 7x plus 10 equals 0. So let's take what we just got and put it equal to 0. Now, to make this equal 0, either the x plus 2 must be equal to 0, or the x plus 5 must be equal to 0. So what we can do is take each of those brackets and just equate them to 0. So we could say x plus 2 equals 0, and then rearrange that to find that x must equal minus 2. Then we can do the same with the other bracket, x plus 5 equals 0, which means that x must equal minus 5. And there we have solved this equation with the solutions x equals minus 2 and x equals minus 5. So the salaries of 80 employees of a company are given in the table below. So we've got this nice little summary table and we're asked to write down the modal class. So what we need to know here is that the modal class is the most common interval. So what we need to do is to go and have a look at this table and find which one has the highest frequency. So I can see that the salary range between £20,000 and £30,000 is the most frequent and therefore the most common. So that is the modal class. And make sure that you write that whole interval. We don't just write 25 or anything, that isn't what they want. They want that interval of salaries. Now we're asked to work out an estimate for the mean salary. So it's a 4-marker this, it's going to be a bit trickier, but there's a really nice straightforward method to it. So the first thing I'm going to do is I'm just going to copy down this table here just so I can scribble all over it, okay? Okay, so to work out an estimate for the mean salary, we need to take the midpoint of the salaries, and then once we've worked out the midpoint, we need to work out what the midpoint times the frequency is. Now, all this is going to be part of our method, so if we fill it all in, all will be good. So the midpoint between 0 and 10,000 is just 5,000, so I'm going to write that in here. The midpoint between 10,000 and 20,000 is 15,000, so I'm going to write that. Midpoint between 20 and 30,000 is 25, 30 and 40,000 is 35,000, and the midpoint between 40,000 and 50,000 is 45,000. So now we're going to times the frequency by the midpoint. So 13 times by 5,000 gives me 65,000. 14 times 15,000 gives me 210,000. Now 25 times 25,000 ends up giving me 625,000. 17 times 35,000 ends up giving me 595,000. And finally, we've got 11 times 45,000 gives us 495,000. So let's remind ourselves of how we work out the mean. So mean is always going to be the sum of values. Now in these types of questions with class intervals, that means the sum of the midpoint times the frequencies. And then we divide it by the number that there are. Now in this case, we're told that we have 80 employers. That in this case is going to be what n is. So let's work out the sum of all those midpoint times frequencies. So we're just going to add up the 65,000, the 210,000, all of those, we're going to add those up together. And we end up getting 1,990,000. And we're going to divide that through by 80, which is n. That gives us now a mean salary of 24,875. And you know, if you look at the salaries that are in the table, it kind of makes sense, doesn't it? Like that is a number that falls in that range. It's actually in that modal class as well, which you'll often find. So let's have a look at the next part. An employee was randomly selected and asked what their salary is. Give the probability that their salary is less than or equal to £30,000. Give your answer as a fraction in its simplest form. So let's remind ourselves of that table, here it is, and let's think, less than or equal to £30,000 is going to be all of these 3 salary ranges. How many people are there in total with those salaries? So we've got 13 plus 14 plus 25 different people. Now, adding those up together, we end up finding that we have 52 people with salaries in that range. Now, don't forget we had 80 people in total. Of course, we can remember it from the earlier part, or we could just add up all those frequencies. Doesn't matter if we forgot that they already said it. So the probability is going to be 52 out of 80, which will simplify down to give us 13 over 20. Of course, we can work that out ourselves, but as we always have a calculator in these papers, you can always just type in 52 over 80 on the calculator, and it will normally give you the most simplified version of the fraction. A person's wage is divided in a ratio of 5 to 3 to 2 between bills, spending money and savings. 60% of the amount spent on bills is rent. Now let's write out this ratio, 5 to 3 to 2. We know that the 5 part of this refers to the bills. And we're told here that 60% of the amount spent on bills is actually rent. Now, we're given the extra bit of information on the next line, that the rent bill is $1,200 per month. That must mean then that the rent is equal to 1,200, which is equal to 60% of the bills. So let's make this little equality here. 1,200 equals 60% of the bills. So if we know that, then we can work out what 1% is. We can go down to 1 by dividing by 60. Now we'll do the same on the other side too. 1,200 divided by 60, which gives us £20. So we know that 1% of the bills is equal to £20. So now that we know what 1% is, we can easily go up to 100% and find the full amount that those bills are equal to. So if we times both sides by 100 to do that, we find that the bills comes to a total of £2,000. So now we know that the total amount of the bills comes to £2,000. Let's include this in our labelling, okay? So I'm just going to add on here that 5 part of the ratio is equivalent to £2,000. Now that I know that, I'm just going to write that as an equality. I'm going to say that £2,000 is equal to 5 parts of this ratio. And it's really important to write everything down nice and clearly like that so that we don't get lost along the way. So now that we know that 5 parts of the ratio is 2,000, we can easily go down to work out what 1 part of the ratio is. And we can do that just by dividing both sides through by 5. So now I'm dividing both sides by 5, and I end up finding that 1 part of this ratio is equal to £400. So now going back to the question, when it says that the ratio 5 to 3 to 2 is between bills, spending money and savings. That means that the savings part of this ratio is represented by the number 2. So ultimately in this question, where we're asked to work out the amount of money saved each month, we need 2 parts of the ratio, which is 2 times 400, which gives us £800. And that there is our answer. A person buys a new car for £65,000. They're told that it's going to depreciate in value by 7.6% each year. And we're asked here to calculate the value of the car after 5 years, giving our answer to the nearest pound. So here we need to remember it's depreciating in value. So if we consider the original value to be 100% and take away that 7.6%, we're left with 92.4%. Now that's really helpful because we can change that percentage into a multiplier. And any of these compound interest or depreciation questions are made so much easier if you have this multiplier. Simply convert that percentage to a decimal, 0.924, and you do that by dividing by 100. So this is how we're going to do it. We're going to take the amount that the car cost, 65,000, and times it by our multiplier to the power of the number of years. Now this method works for any of these questions. Now that we've got this formula, all we need to do is to put it into the calculator. So when I do this, I get to the nearest pound, as the question wants, £43,780. And see how simple that actually was. So let's just go back and think about it again. So we always start with 100%, that's our original value. And if we're depreciating the value, we subtract the percentage. And if it's going up, like compound interest, then we add the percentage. We then find what that percentage is. In this case, it was 92.4%. And take whatever you have and divide it by 100 to get your multiplier. Then finally, we have our original value. That could be how much money you have or how much something cost. And then you times it by our multiplier to the power of the number of years. So in this case, that was 5. It could be something different to years, but probably it's going to be something like that. So it's the power of the number of years in this case. And that's how we do it. And then it's just calculator work. So I hope that's clear and you feel ready to have a go at another question like that in future. A solid bar is in the shape of a triangular prism. Bar has a mass of 1,200 grams. And we're asked to calculate the density of the bar to two significant figures. Now let's remind ourselves of the equation for density. Density is equal to mass divided by volume. Now, in this particular question, we know the mass. We're told that it's 1,200 grams, and that's in the units we want because we need density in grams per meters cubed. But we don't yet know the volume. Now, the volume of a prism like this one can be worked out by using the equation that states volume is cross-sectional area times by the length. So that's what we're going to have to do to work out the volume of this. We're going to have to first work out that cross-sectional area and then times it through its length. Now looking at the diagram, I can see the cross-sectional area is that of a triangle. So I'm going to do half the base times the height. That ends up giving us 1/2 times by 0.2 times by 0.4. And putting that into the calculator, I find that that gives me an area of 0.04 meters squared. So now I can use that to work out the volume. I know that the cross-sectional area now of that equation is 0.04. So I can say that the volume is equal to 0.04 times by the length of this prism, which is 0.9 meters. So I'm going to pop that into my equation too. So volume is 0.04 times 0.9. Now if I pop that into the calculator, I find that the volume is equal to 0.036 meters cubed. Now I do have all the information that I need to be able to calculate the density. Density is the mass, 1,200, divided by the volume, 0.036. So popping that into the calculator, I find that density is equal to 33,333.333 recurring. However, this question, it doesn't just want that as the answer. Always go back, check the question at the end. You can see that they want it to two significant figures, not two decimal places, two significant figures. So that in this case will be 33,000 grams per meters cubed. Here we're told that a gardener wants to place a border around a region of a garden. The dimensions of the region are shown below. So here we can see we've got this 3.6 by 7.5 triangle. However, we don't know the length of the hypotenuse of it. We're told that each roll of border is 5 meters long, and we're asked to work out the least number of rolls of border that the gardener will need. So this means we need to work out the perimeter of this triangle. Now to do that, we need to work out this hypotenuse length. Let's call it x. Now this is a right-angled triangle, so we can work out its length by using Pythagoras' theorem. Pythagoras' theorem states that the length of the hypotenuse squared is equal to the sum of the square of the other two sides. So here we have x squared equals 3.6 squared plus 7.5 squared, which gives us x squared equals 69.21. Now to get x on its own, we need to square root that, which leaves us with 8.319. Now we have enough information to work out the perimeter of this triangle. So let's do that. Let's get this perimeter. It's going to be equal to 3.6 plus 7.5 plus 8.319. And that ends up giving us a total for the perimeter of 19.419. So let's go back to the question now. We're told that each roll of board is 5 metres long. So we need to work out, well, how many of these 5 metre long packs of border do we need? So if we take the 19.419 and divide it by 5, we will see that we get 3.8838. Well, that's how many rolls of border we need. We can't get 0.8 whatever of a border though. So we're going to round up. We're going to see that we need 4 rolls of border, and that is the least number of rolls of border that the gardener will need. The dimensions of a rectangle are given below. We're asked to use the diagram to write down 2 equations in terms of x and y. So what this question's really testing us on here is the knowledge that opposite sides of a rectangle have the same length. So for that reason, we can really easily construct these equations. We can say that the length 2x plus 3y is actually equal to 8. And the same with the other 2 sides as well. We can say that 2y is equal to 5 minus x. And by doing that, very simply, we have our 2 equations in terms of x and y. So next up, we're asked to find x and y. Now, what this has become now is it is a question where we need to solve a set of simultaneous equations. And of course, there's many different ways to solve simultaneous equations. I'm going to show you one way here, but if you use a different method, that's absolutely fine. So in this case, because one of these equations, the second of these equations, looks quite easy to rearrange, I feel like I could get x as the subject to that one really quite easily. So for that reason, I'm going to choose this method to work it out. I'm going to rearrange it to get x on its own, and that will end up giving me 5 minus 2y. Now I know that x is equal to 5 minus 2y. I'm going to substitute x in place of the x in the first equation with the 5 minus 2y. So that gives us 2 times by 5 minus 2y plus 3y equals 8. So if I simplify this by multiplying out the brackets, 2 times 5 gives us 10, and 2 times minus 2y gives us 4y. So plus 3y is equal to 8. Now, collecting like terms here, I know that minus 4y plus 3y gives us minus y. So here we can say that 10y minus y is equal to 8. But now that I've got this, I can see either by rearranging or observation, I can see that y will equal 2. Now, as soon as I know that y equals 2, I can substitute that back into our earlier equation. Remember, we said over here that x was equal to 5 minus 2y. So here I can say that x equals 5 minus 2y, y is equal to 2 now, so that's 5 minus 2 times 2, and that just gives us x is equal to 1. So now I have found both the x and the y coordinates, and I have answered part B. Here we're asked to use our answers from part B to work out the perimeter of the rectangle. Now our answers from part B was of course our x equals 1 and our y equals 2. So I've added in the little diagram here just so that we can look back over it. Remember that the perimeter of a rectangle or any shape is just the sum of all of its sides. So that means we want to do the 2y, and then we want to add the 8, and then we want to add the 5 minus x, and then we want to add the 2x plus 3y. We can do it that way, but I can also do it in a simpler way. 2y is going to be 2 times 2, as of course y is 2. That gives us 4 for that side. Because it's a rectangle, we know that that bottom side is also 4. The right-hand side is 8, and so the left-hand side is 8. So for that reason, we can say that the perimeter is 4 plus 8 plus 4 plus 8, and then we end up finding that final perimeter of 24. And that there is our answer. So the diagram below shows 3 regular pentagons, and we're asked to find x. So when working this out, the fact that they're regular pentagons is really important because it tells us that every angle in the pentagon is identical. Here is a little method that we can use to work out the interior angles in a pentagon. If you take one point and see how many triangles you can draw, I can see that I can make 3 triangles. I know that each triangle has an angle of 180. So that means 3 times that 180 gives us 540. Now that's the sum of all of the interior angles. So if I take that 540 and I divide it by 5 because there's 5 angles in there, I can see each interior angle in a pentagon equals 108 degrees. So see here I can label our diagram, and actually this is becoming quite clear what we need to do next. We know that the angle around a point is 360. So if from that 360 we take away each of those 3 108s, we should be left with just what x is. So here we've got 360 minus 324 gives us what x is, and that gives us 36 degrees. So in this question, the angle x is 36. Find the gradient of the straight line that passes through the points 9, 8 and 0, 5. So this is an equation of a straight line question. So the very first thing we need to do is to write down our equation of a straight line. And this is so important that we learn this, okay? So get this on a flashcard if you don't know it. So this is y equals mx plus c. Now m is the gradient of a line and c is the y-intercept. Now this is the y-coordinate when x is equal to 0. It's where that line's going to cross the y-axis. So now that we've got this equation of a straight line all laid out, we can get to work on working out what the equation of this particular line is. So we've got the coordinates of 2 points. With this we can work out what the gradient of the line is. Let's remind ourselves of what the equation of a gradient is. Gradient is equal to the change in the y-coordinates divided by the change in the x-coordinates. Now you might have learnt that as rise over run. All of them work out the same, okay? Let's look at the y-coordinates that we have here. So we've got 8 and 5. So the change in the y-coordinates will be 8 minus 5. Now let's next look at the x-coordinates. We've got 9 and 0. So the change in the x-coordinates will be 9 minus 0. This ends up giving us 3 over 9, which will simplify to be 1 over 3. So we've got our gradient now. Brilliant. We know what m is going to be in this equation of a straight line. Now we just need to know what the y-intercept is. Well, in this particular question, they kind of helped us out because one of the coordinates is 0, 5 that they've given us. Now that 5 is the y-coordinate when x is equal to 0. So 5 is the y-intercept. We don't need to do any other work to get it. They've given it to us. So I'll make a little note here then that I know that c is equal to 5. And finally, all that I need to do now is just to put this into the equation y equals mx plus c. So y is equal to 1/3 x plus 5. And that is it. A massive well done for getting through that. X is directly proportional to y. Complete the table below. So here we're given the x values of 2, 4 and 6. But we're told that when x is equal to 2, y is equal to 12. And when we have direct proportion, we can say that y is equal to some constant times by x. Well, we can work out what that constant is. We can say, well, if 12 is equal to k times by 2, then k must be equal to 12 divided by 2, which is 6. By using this method, we've really quickly got ourselves an equation that links y and x. So we can say y equals 6x. So now if we look at when x is equal to 4, we can substitute that into this equation. And we find 6 times 4 is equal to 24. So that's our y value. Then we can do the same when x equals 6. 6 times by 6 will be equal to y, which is 36. So there we are, we've done that. Now in B, we're told that x is inversely proportional to y. So here we have y equals k over x. That's what inverse proportion looks like. So in this case, to find the constant k, we can do y times by x. Now we know that when x equals 3, y equals 12. So we can substitute these numbers into this formula to find out what the constant k is. K is equal to 12 times by 3. So k equals 36. So if we now go back to the equation, y equals k over x, we can put in place of the k 36. So here we've got y equals 36 over x. Now that we've got this formula, we can go back to our table and we can say that when x is equal to 1, we can substitute that in. So y will be equal to 36 divided by 1, which is simply 36. Now we'll do exactly the same when x equals 2. We're going to say that y is equal to 36 over 2, which gives us 18. And so there we have completed our table. If A equals BC, work out the percentage increase in A if B increases by 10% and C increases by 8%. So the way that I would like to do this is first work out if B has increased by 10%, what is the relevant multiplier? And the multiplier is found by doing 100% plus 10 and then turning that to a decimal. So the multiplier for a 10% increase is 1.8 and the multiplier for an 8% increase is 1.08. Again, just 100% plus 8 divided by 100. So because A is equal to B times C, the increase that A is going to see is going to be the product of those two increases. So here we can say that the increase in A is going to be equal to this 1.1 times by 1.08. Now that will give us 1.188. Now that's a decimal, okay? We need the percentage increase. So we're going to kind of go backwards from how we found the multipliers before to turn it to a percentage. If we times this through by 100, we have 118.8%. That's how much it is compared to its original value of A. And the original value would have been 100%, wouldn't it? So to be now 118.8% of the original value, it was the 100 plus an increase of 18.8%. So our answer to this question, the percentage increase in A, is 18.8%. Given that A times 10 to the m is in standard form, and 2 times 10 to the q divided by 8 times 10 to the p equals A times 10 to the m, find the value of A. So to do this, I'm going to look at that division and I'm going to take it bit by bit. I'm going to first work out what 2 divided by 8 is, so dealing with the numbers first. I know that that gives us 0.25. So now I'm going to have a look at the indices. So I've got 10 to the power of q divided by 10 to the power of p. So we should remember that when we divide these powers, we have to subtract the indices. So that means that here, where we have 10 to the q divided by 10 to the p, that will give us 10 to the q minus p. So we're nearly there now, okay? But the key thing is that A times 10 to the m is in standard form. Now what we have here isn't in standard form because the number part, the 0.25, isn't a number bigger than or equal to 1 but less than 10. It cannot be a decimal, it can't be 0.25. The smallest number that it can be is 1. And the reason for that is simply that is just what standard form is. So if they ever ask you for standard form, that number part of it has to be at least 1 but still less than 10. So let's have a look at what we need to do then. What we can do to fix this is if we essentially bump up the 0.25 by a factor of 10, but then decrease the other side, the power, by a factor of 10, they're going to even out, but the number will look different. So what we'll have is 2.5 for the number, and then the index will become times 10 to the q minus p minus 1. And the reason why it has become that is because if we have this 10 to the q minus p and we divide it by 10, essentially what we have here is something that where we can use our index rules again. So if we divide it through by 10, it's essentially 10 to the 1, isn't it? And we know that when we divide these indices, we subtract. So that's where we're getting our q minus p minus 1 from. So now we have something which is indeed in that standard form. So what we've got here is a times 10 to the m. So now we've done this, we have the answer to part A. A is equal to 2.5. So if we now look at question B, you can see they wanted us to write down an equation for m in terms of q and p. And we have that really, don't we? Because if we look and compare, we can see that this q minus p minus 1 is equal to m. So actually, quite simply, we can just say that m equals q minus p minus 1. And that there is your answer. Here we're asked to solve for x, this equation, giving our answer to 2 decimal places. So the equation is x squared equals 3 brackets x plus 1. Now here I can see a big hint as to how to do this. I can see this massive hint in the question that we need to give our answer to 2 decimal places. Now, when I first look at this question, I can see that there's some squared things. Maybe it's a quadratic equation. Maybe I can factorise it. But the fact that it says here to 2 decimal places tells me I can't factorise it. I'm going to have to use the quadratic formula. And that's a top tip if you ever have something that looks like a quadratic equation, but they want the answer to 2 decimal places, in all likelihood, you're going to have to use quadratic formula. So let's get started with multiplying out this equation so that we can get it in that standard format that we need. So here we're going to have x squared is equal to 3 times x gives us 3x, plus 3 times 1 plus 3. I'm then going to rearrange this to get everything over onto the left-hand side so that it's equal to 0. So here we have x squared minus 3x minus 3 equals 0. So I've just subtracted both the 3x and the 3. So now that we've got our quadratic equation and we've established we need to use the quadratic formula to solve it, I'm going to write it down. So the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. And the a's, the b's, the c's come from comparing our equation with ax squared plus bx plus c. And as you can see here, and I always do this before I use this formula, I'm going to write down what a is. A is 1, b is minus 3, and c is minus 3. I always do that first because I think that's one of the #1 places people make mistakes. So now I'm going to substitute these values in, and because some of them are negative, I can't stress enough the importance of brackets. This is the other main place where people make mistakes, particularly with that squared. If we just do minus 3 squared without the brackets, you will get the wrong answer. So let's have a look at what we have here. So we have minus b, which is minus 3, plus or minus the square root of the square of minus 3. Do not forget those brackets. Minus 4 times 1 times minus 3. And that's all over 2 times 1 from the 2a. So now that we've done this, we can either just put it straight into the calculator or we can simplify a little first. I'm going to simplify, but you don't need to. The minus 3 just makes positive 3. The bit under the square root ends up giving us 21. So here we have 3 plus or minus the square root of 21 over 2. Now this gives us two answers. Here I have 3.79, which I get by putting the plus into this formula, but then we need to go back through it and replace the plus with a minus, and that's when I get my other answer for this, which is minus 0.79. We need to have both of these written down to get the marks. It's worthwhile remembering that most of the time, not always, but most of the time we will get two solutions when we have a quadratic equation. So if you only get one, just double check again that you haven't missed one. So that's good. So those are our two answers given to the two decimal places that the question wanted, 3.79 and minus 0.79. The following table represents the frequency of the ages of 300 participants in a marathon. So here you can see we're given a table with the number of participants, but we're asked to complete the cumulative frequency part. So cumulative frequency is all about looking at what's up to that point, so everything that came before it as well as in that interval. So let's get started. So in our first cumulative frequency box, we're just looking at everything up to 25. And because this is the first interval, it's just going to be that 15. So we'll put 15 in the box. Next, we are asked to do the cumulative frequency of everything up to 35. So to do that, we need to add together the 15 and the 45. So that's going to give us 60. So next we need the cumulative frequency up to 45 now. So that means that we also want to add on the 70. So that gives us now 130 for the cumulative frequency up to 45. Next we need the cumulative frequency up to 55. To get that, we're just going to add 90 onto the 130 we already have, getting 220. And to get cumulative frequency up to 65, we need to add that 80, which gives us 300, which makes sense considering that we have 30 participants in this marathon. That is what we would expect. So now we're asked to draw a cumulative frequency graph to represent this data. So let's remind ourselves of the information we had on the previous page. The thing that we most importantly need to know here is that we use the final number in each interval. So here we're going to plot the point on the x-axis of 25 because that is the end of the age group interval. So 25, 15 is going to be our first point on this cumulative frequency graph. So the next point now is going to be at 60 on the y-axis, but 35, again, the end of the interval for the cumulative frequency. So here we've got 35 at 60. The next point will be 45 on the x-axis, the end of the interval, and 130. So we'll plot that point now. So 45, 130. Then now we're going to do the 55. So we go along at 55 along the x-axis, and then we're going to go up to 220. Now we're on to the final point. We need to plot a point at the end of the interval again, so that's 65 and 300 high. Now we've got all these points, we need to draw a curve. Always remember to start at the point 0, 0, and then you're going to go up through each of those points, making sure you go through them all. And there we have our cumulative frequency, which starts at 0, 0 and ends at 65, 300. Here we're asked to work out the percentage of participants that are aged 35 or younger. So let's have a look at the table here. I can see that up to 35, we have 60 people. We can either look at our cumulative frequency, or we could add up the 15 plus the 45 again. So we know we have 16 people who are 35 or younger, and we also know that we have 300 people in total. So that means that we have 60 people out of 300. So to get that as a percentage, we're going to do 60 divided by 300 and then times it by 100. Now that gives us an answer of 20%, which is our answer here. If a participant is chosen at random, work out the probability that they are aged 50 or older. So to answer this, I want us to have a look at our cumulative frequency graph again. So 50 or older, let's use our graph and move a line up from 50 until it hits our curve, and then we're going to read across to see what the cumulative frequency is. So we're reading across, drawing a horizontal line here, and we'll find that the cumulative frequency appears to be around 170. There'll be a little bit of leeway here in the exam because of course it depends on your curve. So 170 people are going to have an age below 50 because it's cumulative, it goes from small up to big. However, this question wants us the probability of people aged 50 or older. So if we know 170 people are younger than 50, if we do 300 minus 170, we'll find that we have 130 people above 50 years old. Now that is what we can use to work out the probability of being 50 or older. That's going to be the 130 divided by the total number of people. So that there gives us 13 over 30. They just said work out the probability. We could give that as a percentage, but there's no need. That is absolutely fine as a simplified fraction. So our answer to this question, the probability that they're aged 50 or older is 13 over 30. Given that 2 minus root a squared is equal to 3b minus 16 root 2, where a and b are positive constants, find a and b. So to answer this question, first let's simplify this a bit. Let's work out what 2 minus root a squared is. And we'll do that by writing the double brackets. Remember, don't just square the 2 and the root a because it will be wrong. So 2 times 2 is 4. 2 times minus root a is simply minus 2 root a. Minus root a times 2 is minus 2 root a. And minus root a times by minus root a gives us positive a. So what we've got here is something that we can now simplify. Let's get those like terms all together here. Minus 2 root a minus 2 root a gives us minus 4 root a. So in total we have 4 minus 4 root a plus a. Now let's compare that to this 3b minus 16 root 2. What we need to understand to do here is to compare coefficients. So let's first compare the surds. Here we can say that minus 4 root a equals minus 16 root 2. And likewise we can do the same with the constants, the ones that don't have any surds. So here we can say that 4 plus a equals 3b. They're all the ones without surds. And then we can say that with the surds, minus 4 root a equals minus 16 root 2. Let's get started with the bottom equation here though, because there's only one unknown. There's only a. So here, if we try and get root a as the subject, we can do that by dividing both sides by minus 4. So if we take minus 16 root 2 and divide by minus 4, you're just left with 4 root 2. So that means to get the a on its own, we just need to get rid of the square root. So if we square both sides, we'll find that a equals 4 root 2 squared, which will equal 32. So here we know now what a is equal to. We've got one of our answers already. To find out what b is, let's go to our blue equation, the first one that I wrote down. We know that 4 plus a, which is now 4 plus 32, is equal to 3b. This means that 36 is equal to 3b, which, if we divide both sides by 3, we will find that b is equal to 12. So in this question now, we know what both a is and b is, and we have answered our question. So a is 32 and b is 12. simplify the following, and here we have 1 over x minus 1 minus 1 over x minus 3. Now we have two algebraic fractions here. In order to simplify this, we need to turn it into one big fraction. And to do that, we need to get the denominators the same. We can do this by timesing the 1 over x minus 1 on the top and the bottom by x minus 3. So we have 1 times x minus 3 on the top and x minus 1 times x minus 3 on the bottom. Now we're going to do the same thing on the other side, but this time we're timesing the top and the bottom by x minus 1. The whole purpose of this is we haven't changed the values of either of those fractions. We've essentially times by 1, but they're going to look a bit different. They're going to have the same denominator. So starting with the first one, we have just x minus 3 on the top. On the bottom, we're not going to do anything fancy here. We're just going to rewrite it as x minus 1, x minus 3, making sure we have the two sets of brackets there. Now over on the other side, we've got 1 times x minus 1, which is just x minus 1. And again, on the bottom, we have x minus 3, x minus 1. So now we've got the same denominator. Doesn't matter that they're written in different orders on the denominators, however you write it, they are the same. Now that we have the same denominator, it means that we can add or subtract these fractions. And in this case, obviously, it's a subtract. I will say, please be very careful when there's a subtract, particularly when it's an algebraic fraction. So here we have x minus 3 minus, and see I put brackets here, x minus 1, over x minus 1, x minus 3. Now the reason why I put those brackets there is because we could completely go wrong if we don't count them. That negative has to apply to both the x and the minus 1 of that second term, not just the x. That would be the very easy mistake to make. You just plonk it in front of x minus 1 and away you go. But you would not get it all right. And it's only a 2-mark question. Let's not lose those precious marks. So here we have x minus 3, but then it's going to be minus x. And then because it's a minus and a minus, it will be plus 1. And that's all over x minus 1, x minus 3. So now we're nearly there. We can just simplify the top. Here we can see we have some x's, but it's x minus x. So actually you'll see that the x's will cancel. And then you have minus 3 plus 1, which is going to give us minus 2. So here we have minus 2 over x minus 1, x minus 3. And that there is our answer all finished for you. So that's how we simplify two sets of algebraic fractions, added or subtracted to each other. First you get your common denominator, and then you add or subtract them to simplify. The fourth term of an arithmetic sequence is equal to 12. The 12th term of the arithmetic sequence is equal to 84. Here we're asked to find the value of the 100th term of the sequence. So for us to do this, let's first write down this equation which enables us to find the value of the nth term. So an is equal to a plus n minus 1d. Now the an in this case is our nth term, so say our 4th term or our 12th term. A is the first term of the sequence. N is the number of terms in your sequence. And D is our common difference, so by how much each term goes up compared to the last. Now, this equation and knowing what each of these parts of it mean is very important for GCSE maths, because in a question like this, you need to put it into practice. Let's get started by thinking about this first sentence. We're told that the 4th term of an arithmetic sequence is equal to 12. So that means that A4, the 4th term, is 12. And n is 4 in that case. So if we plug these numbers into what we have in this equation, we can say that 12 is equal to A, which we still don't know, plus 4 minus 1 times D. Now simplifying that, we get the equation 12 equals A plus 3D. Now that we've done that, let's look at the second sentence above. Here we know that n equals 12, it's the 12th term, and that is equal to an nth term, a 12th term of 84. So here we can see that 84 equals a plus 12 minus 1d. And this will simplify to give us 84 equals a plus 11d. So now we've got a set of two equations. There's two unknowns, a and d. And so what we have here is a pair of simultaneous equations. And we need to solve these to work out what a and d is so that we can get this 100th term that the question wants. Now there's loads of ways to do simultaneous equations, but this is how I'm going to do this one. I can see that the a's are the same, and because the same sign, we're going to subtract. Same sign, subtract. So we're going to subtract those two equations from each other. 12 minus 84 gives me minus 72. And 3d minus 11d gives me minus 8d. So I'm going to write that down underneath now, minus 8d. Now with this information that we have, I can rearrange this minus 72 equals minus 8d to get d on its own, just by dividing through by the minus 8. So d is going to equal minus 72 divided by minus 8, which gives us 9. Now to get a, we can substitute that value of d into either of our equations. Both will work. Let's use the top one. 12 equals a plus 3 times d, which now we know is 9. So we substitute that in place. So 12 equals a plus 3 times 9. Now 3 times 9 is of course 27, so let's replace that there. So a is going to be equal to 12 minus 27, which gives us a equals minus 15. So by solving those simultaneous equations, we now know that a is equal to minus 15 and d is equal to 9. So now we have all of the information that we need to be able to find the 100th term of the sequence. So going back to our key equation here, the 100th term is going to be equal to minus 15 in place of a plus 100 minus 1, because we've got the 100th term of the sequence that we're looking for, times by d, the common difference, which we said was 9. So a100 is going to be equal to minus 15 plus 99 times 9, which gives us 876. So that is the value of our 100th term of the sequence. Here we have a bit of a bumper algebra question. So to start us off, we need to simplify 2ab squared c to the minus 2 times by 9b cubed c. So because we're timesing here and there are indices involved, I'm going to remind you of an equation that we need to use in this. We should know that x to the power of m times by x to the power of n equals x to the power of m plus n. So when multiplying, we add the indices. Now, looking at this question, I can see that I've got A's, I've got B's, I've got C's. I want to take those one at a time. I'm going to start off by just using the numbers. 2 times 9. Don't need any tricks for those. I know that 2 times 9 is 18. Now I'll look at the A's. And I can see there's actually only one A here, so it's just A. But now we look at the B's, and this is where we're going to use our rule. We've got b squared times by b cubed. Now that's going to be b to the power of 2 plus 3, which is going to give us b to the power of 5. And now we're going to do the same with c to the power of minus 2 times by c. Don't forget that c, it hasn't got a power written there, but it's actually to the power of 1. So here we need to do c to the power of minus 2 plus 1, which of course is going to give us c to the power of minus 1. And there we've done part A. So part B is very similar, but it's also got a division in it. So before we get started on this one, let's remind ourselves of another equation. We should know that x to the m divided by x to the power of n is equal to x to the power of m minus n. So when we divide different powers, we're going to subtract from them. So that's going to come into practice here. So here we have x to the power of 7 times by 2x divided by x to the power of minus 1/2. Now I would start off here by simplifying the top. Let's remember that x is really x to the power of 1. That's going to simplify to give us 2x to the power of 8. And it's still all over that x to the minus 1/2, because we're going to look at that now. Now because we're dividing, that means we're going to subtract their powers. So here we have 2x to the power of 8 minus 1/2. That will simplify to give us 2x to the 8.5, and that there will be our answer. You can give 8.5 as a top-heavy fraction or as 8.5, doesn't matter, you're going to get the marks regardless. So now for C, this is a power of a power question. So we've got a whole another rule now that we need to know. We should recognise that if we have x to the power of m to the power of n, we multiply the powers. We've got x to the power of m times n. So in this case, we've got 2y to the 5 to the power of 3. Let's do the number bit first. Now again, a number is just a number. We don't need any fancy tricks. We just need to do 2 cubed, which is 8. But with the y to the power of 5 to the power of 3, we need to use our rule. So that's going to be y to the power of 5 times by 3. So there we get 8y to the power of 15. And that is our answer. Last one now, okay? So here we've got 27 over x to the power of 6 to the power of minus 1/3. So when simplifying things like this, it's important that you know that a negative power tells us to do the reciprocal. Now when we do the reciprocal of a fraction like this, all it means we need to do is to flip it upside down, to essentially invert it so that what was on the bottom is now on the top and what was on the top is now on the bottom. So we can rewrite this now as x to the 6 over 27. And we're just going to write it to the power of a third because we've already done the minus bit now. The next thing that we need to know is when we have a fractional power, what's on the bottom of that power tells us what root to do. So this 3 here tells us we need to do the cube root. Now, as we have a fraction here, we need to do that cube root to both the top and the bottom. Now, when doing the cube root to the top though, we really would be better placed just using our power rule. Whereas on the bottom, when we have the cube root of 27, we can just do that using numbers. So let's first get started on the top here. Yes, we said to the power of a third means take the cube root. But what does that really mean when we have x to the power of 6? Really, we're better off using our power of a power rule. So we could say x to the 6 to the power of 1/3 is the same as x to the power of 6 times a third. Whereas on the bottom here, we should recognise that the cube root of 27 is 3. Now simplifying this now, if we go back to x to the power of 6 times 1/3, 6 times 1/3 is 2. So here we get x squared divided by 3. Or we could write it as 1/3 x squared. They both mean the exact same thing. But gosh, that question was quite a heavy one, I think. Quite a lot to do, quite a lot to think about. But the key thing is make sure that you're familiar with all of these rules that we've used here. And if you're not, then get writing some notes or making up some flashcards so that you do know these, because these will come up in your exam. A hollow cylinder is filled with 3 identical spheres. The radius of the spheres is the same as the radius of the cylinder. Find the fraction of the cylinder that remains empty. So to answer this, we need to work out the volume of the cylinder that remains empty. To do that, we're going to need to work out the volume of the cylinder in the first place, and then subtract the volume of the 3 identical spheres. Now don't be worried here about the fact that we don't have any numbers. It's fine, we know enough. Let's have a go at just labelling this, okay? We know that the radius of the spheres is the same as the radius of the cylinder. In that way then, we can draw on the radius on our diagram, and then we can also draw in terms of the radius, the height of this cylinder. As 3 spheres fit in it, it's going to have a height which is equal to 6 radii. So now that we know this, we can go back to our standard equation for the volume of a cylinder. We know that the volume of a cylinder is pi r squared times by the height h. So substituting in 6r in place of the height gives us 6r squared times by 6r, which simplifies to give us 6 pi r cubed. So we've already done the first part of this question. Now let's have a go at working out the volume of a sphere. We should know that the volume of a sphere is given by 4/3 pi r cubed. Now, in this case, as we're not looking for the volume of one sphere, we're looking for the volume of 3 spheres, all we're going to need to do is take this and multiply it through by 3. So the volume of the 3 spheres is equal to 4 pi r cubed. So now we've got this information down, we can go and work out the volume of empty space. So it's going to be equal to 6 pi r cubed, which is the volume of the cylinder, minus 4 pi r cubed, which is the volume of 3 of those spheres. Now simplifying this, we're left with 2 pi r cubed. So that is our volume of empty space. Now going back to the question, we're asked to find the fraction of the cylinder that remains empty. So that's going to be equal to that volume of empty space divided by the volume of the cylinder. So we have 2 pi r cubed over 6 pi r cubed, which simplifies down to just 1/3. So 1/3 of this cylinder remains empty. A group of 49 students took part in a survey to find out how much time they spent using social media each week. So you can see the information in this table here, and we're asked to complete the histogram. Now the most important thing about histogram is that the frequency isn't the height of your bars, it's the area of them. Area is the frequency. So they've already given us one of the bars here, and we know that the area of that must equal 5 because it is equivalent to a frequency of 5. So these are all rectangles, aren't they? And we know that a rectangle has the area found using the base times the height. So base times height will give us the frequency here. Well, looking at this bar, we already know it has a base equal to 10, which must mean that it has a height equals to 0.5, because 0.5 times 10 gives us that 5 of the frequency. So now that we know this is really important. We can start to label on the scale of the graph. So if we know that that height is 0.5, then we know that each tiny little part of the grid is equal to 0.1. Now that's what we need to know to complete this histogram. So let's add in a couple of extra bits up the scale. We've got 1.0, 1.5, we could carry on. So the next bar that we need to draw has a frequency of 10. Now that means that the area of it has to equal 10. Now looking at the range goes from 10 to 20, it means that its base in this case is also going to equal 10. That's how we find out the base of it. It's how big is that interval, in this case the number of hours. So using the fact that base times height equals frequency, we know that there's a base of 10, because there's 10 numbers from 10 to 20. We don't know how tall it's going to be yet, but we know it has a frequency of 10 because that's given in the table. Using this information, we can say that this has a height equal to 1. So we're going to draw a block which goes from 10 to 20 on the bottom, but reaches up to 10. Now make sure you're using a ruler and a pencil in the exam. So now we've got the interval of 20 to 30, which has a frequency of 22. Again, we're going to use the fact that base times height equals frequency. Now in this case, the base, because it goes from 20 to 30, it has that width again of 10. So when we're drawing it on the graph, we're going to go, it has a base of 10 times the height equals 22 for the frequency. That means the height is equal to 2.2. So if we go to the grid, the base goes from 20 to 30 and it goes up to 2.2. So it might be helpful just to label on where 2.0 is and where 2.5 is. So now we can do that quite easily. So we're going to have a bar which goes 20 to 30 on the base, up to 2.2 on the top. Remember, each little rectangle on the y-axis is representing 0.1. So here we are, here's our bar. Again, please make sure that in the exam you are using a ruler and a pencil. So the final bit now, okay, we have a frequency of 12, and that corresponds to the number of hours going from 30 all the way up to 50. So this one's wider than the other ones we've had before. It has a width equal to 20. Now that means that the base of this that we use is going to be equal to 20. And we know the frequency is equal to 12. So here we can say that 20 times by that height that we need to find is equal to 12. Now rearranging this, the height will be equal to 12 divided by 20, which is 0.6. So we're going to do a bar, which is much wider. It goes from 30 to 50 on the x-axis, and then it goes up to 0.6. And there's your answer. Just make sure in the exam, I can't say it enough, you're using a ruler and a pencil. So now we're asked to find the proportion of students who spend over 36 hours each week using social media. So let's remind ourselves of our graph. We were told earlier that we have 49 students in total. That was given in the beginning of the question. Here we're looking at people spending over 36 hours. So let's draw a little line on our grid that represents 36 roughly. So the region that I'm colouring here is going to be the frequency of people who spend over 36 hours each week using social media. Now 36 up to 50 gives us this base of 14. And the height of that particular block we worked out earlier to be equal to 0.6. So don't forget that we know that the frequency of these bars is equal to their base times their height. So in this case, it's going to be equal to 14 times by that height, which is 0.6. So timesing those together, we end up getting an answer equal to 8.4. So here we can say that the approximate number of people spending over 36 hours each week is 8.4. But this question wants a proportion given as a fraction in its simplest form. So to do that, we're going to take that 8.4 and divide it by 49. Now what I recommend you doing right now is just putting that into the calculator. So we're going to put into the calculator 8.4 over 49. And that gives me an answer of 6 over 35. And that is our answer as a fraction in its simplest form for the proportion of students spending over 36 hours each week on social media. A particle moves in a straight line from O to A. The displacement s meters of the particle from O at time t seconds is given by s equals t cubed minus 6t squared minus 36t minus 3. And we're asked to find the displacement of the particle from O at t equals 2 seconds. To answer this, we should know that s is the displacement, and they do tell it to us in the question. So to find the displacement of the particle from O at t equals 2 seconds, all we need to do is to substitute in place of t 2. So here we have s equals 2 cubed minus 6 times 2 squared minus 36 times 2 minus 3. and that ends up giving us an answer equal to minus 91 metres. So part B asks us to work out at what time the particle is instantaneously at rest. We should know what instantaneously at rest means. It means that the velocity is equal to 0. Now we also need to know that ds dt is the velocity. So if we differentiate the displacement with respect to time, we find velocity. So that's going to be what we need to do. We need to differentiate our function and then put it equal to 0 and solve it. Now, when differentiating, what we do is we take the power and we multiply through by that power, and then we subtract 1 from the power. So 3 minus 1 is going to give us 2, isn't it? So t to the power of 3 differentiated is 3t squared. So now let's have a look at minus 6t squared. Again, we're going to times through by the power. So minus 6 times by 2 gives us minus 12. Then again, we're going to subtract 1 from the power. So we've got t to the power of 2 minus 1, which is just t to the power of 1. But don't forget that we don't ever bother to write to the power of 1, do we? So actually we can just ditch that. Of course, if you leave it, it's fine, but really we would just ditch that. So now let's look at minus 36t. Well, there's no obvious number there, but remember, if it just says t, it means t to the 1. So we're still going to times through by that power. That just leaves us with minus 36 because we're just timesing by 1. And then we have t to the power of 1 minus 1. Well, of course, that's t to the power of 0, isn't it? And remember, anything to the power of 0 is just 1. So we can just absolutely just ditch that part. We can say that's equal to 1, so we don't need to write it down. Essentially, you've just got 36 times by 1, which is still 36. Minus 3 differentiates to make 0, and that's the same for any constant. So we finish this now. We said that the differential ds dt has to equal 0. So now we've got 3t squared minus 12t minus 36 equals 0. Now, as all of these are multiples of 3, let's cancel it down. If we divide 3t squared minus 12t minus 36 by 3, you can see we get this here. We get t squared minus 4t minus 12 equals 0. So what we're left with here is a quadratic equation that we can factorise. So that's double brackets that we want. We need two numbers that are going to multiply together to give us minus 12, and that are going to add together to give us minus 4. So we need to stop and have a little think. What numbers do multiply together to give us minus 12, but will also add together to give us minus 4? And the answer here is going to be minus 6 and plus 2. So here we have t minus 6 times by t plus 2 equals 0. Now, because this is equal to 0, each bracket could equal 0. And that enables us to get these answers where we can say that t would equal 6 or t could equal minus 2. Now, because we're talking about time here, we're not just talking about any old letter. We're talking about time. Time can't be negative, can it? So for that reason, we can cross out t equals minus 2 and just be left with t equals 6. And so the answer to this question, the time that the particle is instantaneously at rest, is t equals 6. Here we need to find the acceleration when t equals 5. Now we should recognise that the double differential of s is the acceleration. And well, let's think about it. We differentiated s once in the previous question. And so to get what we need here for the acceleration is we need to differentiate again. We're going to take the answer that we got for part B and we're going to differentiate that again to get the acceleration. So we said that ds dt was equal to 3t squared minus 12t minus 36. So let's use this method again. We're going to take the power and multiply through by the power. That gives us 6. And then we subtract 1 from the power. 2 minus 1 just gives us 1. And of course we don't have to bother writing that, so we can just say 6t. So now let's look at the next term. So we've got minus 12t, that's minus 12t to the power of 1 really. So now we're going to multiply through by that power, and then we're going to subtract 1 from that power. So 1 minus 1 gives us 0. So here, because t to the 0 is just 1, that is just going to be minus 12. And we'll get used to that. We won't have to go through that process every time. We'll just recognise if it's just a t or an x, it will just go away during differentiation. Now likewise the minus 36, we will also just know that constants always differentiate to 0. So here we now have that the acceleration is equal to 6t minus s. Now this question wants it specifically when t is equal to 5. So let's substitute that in. 6 times 5 minus 12 gives us 30 minus 12. And that gives us 18 metres per second squared. So the acceleration when t equals 5 equals 18 metres per second squared. The function f of x is given on the graph below, and we're asked to draw on the grid the function minus f of x and to label it a. Now this is a transformations question, so we need to be really familiar with what every standard transformation does to a graph. So in this case we have minus f of x. Now we need to know that when we have minus f of x, that it's asking us to carry out a reflection in the x-axis. And so that's what we would need to do to this particular curve here. We need to look at the x-axis and reflect any of the key points. So if we look at the minimum point of this curve at the moment, which is at the coordinate minus 2, 1. If we reflect that in the x-axis, that gives us the coordinate of minus 2, minus 1. Likewise, this point where the curve crosses the y-axis, which is the coordinate 0, 6, when we reflect it, it's going to be 0, minus 6. So now we've got enough points to draw the reflection here. And remember, it's just a sketch. So long as you've got some of the key points in the key place and the general shape is correct, then you will get your marks. So now we're asked to draw on the grid the function f of x plus 2 minus 2. So there's two things going on here. Again, let's remind ourselves of those standard transformation parts. So here if we have f of x plus a, so the plus a is in the brackets, that's the critical bit here. What that is asking us to do is to translate the curve f of x by minus a in the x-axis. And I always find when it's in the brackets, it kind of does the opposite of what you would think. You know, you'd think plus a, but no, it's in the brackets, so it's going to do the opposite. It's going to do minus a. So now we have f of x plus a, so outside the brackets there. So here, again, it's a plus or a minus, so it's a translation or a shift. But this time, it's going to be by plus a in the y-axis. Now in this case we do go with plus a because it's outside the brackets, so we do what they want us to do, okay? So looking at this particular curve, we've got f of x plus 2 in the brackets, so that means we're going to go by minus 2 in the x-axis, and then that minus 2 on the end means that we're going to do minus 2 in the y-axis. So let's take a look at that minimum point on the curve again, and let's shift it by minus 2 in the x, and then by minus 2 in the y. By doing this, we can see that the new minimum point needs to be at the coordinate of minus 4, minus 1. And then the rest of the shape of the curve is going to be unchanged. It's still going to be that U-shaped curve. So we're going to draw it now with the minimum being at that point of minus 4, minus 1. And like I said before, so long as the general shape is correct, it doesn't have to be flawless, okay? Remember, this is asking you to sketch or draw on this curve. It's not asking for like a perfect example. So here we are, this is how we would do it. Now, if you're unfamiliar with what I wrote down here, this minus f of x and what it means, or what the f of x plus a in the brackets means, I would recommend that you start making some notes on that and get learning what it means, because really these are quite easy marks in the exam, but without knowing these, you're not going to be able to answer them. So that sounds like the perfect opportunity to get a flashcard out. I hope that that's making a lot more sense now.
And well done for making it to the end of this paper. I'm really, really proud of all of your hard work.